Once you start programming in Python, you'll often encounter constructs that might seem strange and unfamiliar to you. Python tries to make things very simple for you and gives you many powerful constructs. One of those is lambdas. Lambdas are basically anonymous functions, functions which have no name. These are use and throw functions. You don't want to call this function over and over again. You simply want to define it, use it quickly, and then you don't want to reference it ever again. And here is how you define a lambda function. Let's break down exactly what's going on in here. A lambda function, that is a function with no name, is always preceded by the keyword lambda. And after that keyword, we specify the input arguments for this function. This lambda function takes in two input arguments, x and y. Lambda functions do not use the def keyword. They are for named functions. They use the lambda keyword instead. The input arguments are not specified inside brackets. They are simply written after the lambda keyword. That's followed by a colon. And then within one line, you specify the body of the lambda. Lambdas tend to be short and sweet. A lambda is made up of simply a single command. Here, this lambda takes in x and y, adds x to y, and that is what will be returned. You do not specify return statements within lambda. Whatever calculation you perform within the lambda, the result of that will be returned. Lambda functions can be assigned to variables just like values can or expressions can. So this lambda function we assign to the add underscore fn variable. Once you have it assigned to a variable, you can simply invoke this lambda function by calling add function and passing in the input arguments. Basically, once you've assigned the lambda to a variable, you invoke the lambda just like you would any other function. This time you use the variable name instead of the function name. Our lambda adds 3 to 4 and gives you the result 7. We can try it with different values as well. Call add function 4556. It will give you the result 101. If you're no longer interested in having a reference to this lambda around, you can simply call del and specify the name of the variable which stores the lambda. The add function lambda will no longer be accessible in this program. Lambda functions in Python are typically used with lists. If you want the same operation to apply to all elements of a list, you'll use a lambda, because once you applied it to all the elements of a list, you do not have need for that lambda function again. We're going to go ahead and define a list of numbers, that is sum underscore list. We'll now define a lambda function which basically checks for all numbers which are greater than 50. This lambda function takes in just one input argument, x. It will return true if x is greater than 50, false otherwise. We'll assign this lambda function to the greater than 50 variable. In order to apply this lambda function to every element of our list, we can use the built-in filter function. The filter function is available directly for you to use. The first argument to the filter function is our lambda. The filter function expects a function as its first input argument, and it will then apply this function to every element of the list. The function here we've specified in a lambda. You can use traditional named functions with the filter function as well. The second argument to the filter function is the list on which you want to operate. It will apply the function to every element of the list. The function that it applies is basically a conditional evaluation of what elements will be present in the resultant list. And this is stored in the result variable. Print out the result, you'll see it's some kind of filter iterator class. An iterator basically goes through every element of the list. If you want the actual list, simply pass the result to the list function. And there you get it, a list of all the elements from the original list which are greater than 50. Which were true for our conditional evaluation using the lambda. You can define lambda functions to work on any kind of list. Here is a list of names. We want to find all names which have length greater than 4. In Python, you can do this with one line of code if you do not use intermediate variables to store the values of your lambda functions, of your result, and so on. The expression or the command that you see on screen is pretty complicated. Let's evaluate what's going on. In order to evaluate this, we have to start from the inside and move outwards. Notice that the innermost function is the filter function. The filter function takes in two input arguments, a function and a list. The function we've defined in the form of a lambda, a use and throw function with no name. The lambda basically takes an element of the list, that is the name element, finds the length and checks whether the length is greater than 4. If that element of the list has length greater than 4, it'll return true, it'll return false otherwise. This lambda operates on the names list. That's the second argument to the filter function. The result of the filter function is an iterator, and this result is what is passed into the outer list function, and we get as a result the actual list of all names with length greater than 4. Lambda functions are not just for conditional evaluation. You can also use it to act on elements of a list and get a new element derived from the old element. Here is a lambda function that I'm assigning to the increment by 3 variable. This takes as its input an element and adds 3 to it. So the return value from this lambda is the original element incremented by 3. If you want to get a new list by applying some kind of function to every element of the old list, you'll use the built-in map function. The map function takes in 2 input arguments. The first of these is a function that will help us generate the new element for every old element. The second input argument to the map function is the original list. Here we want to operate on our list of numbers, and we want to apply the function which increments every number by 3. We pass the result to the list function and we get our resultant list. Every number in the original list has been incremented by 3. You can do a quick comparison to check whether this is true by printing out the value of the original list. Here are the numbers in some list. Notice that every corresponding number in the resultant list is the number in some list plus 3. Here is an example where we've used the map function on a list of names. We want to append boo to every name on our list and get a new list with boo appended to every name. Once again, you should parse such functions from the inside to the outside. The inner function is the map, which takes in a lambda and a list of names. The lambda adds the string boo to every name. We then pass the result of the map function to the list function to get the list of names with boo appended. Another common place where you'd use lambdas is in the reduce function in Python. Here is a list of numbers. We'll now see how to use the reduce function in order to find the sum of all the numbers in this list. Here is how you define the lambda to use in the reduce function, which finds the sum of all numbers. This lambda is a little confusing though, because it takes in only 2 input arguments, x and y, and returns x plus y. How does it find the sum of all numbers in a list? When this lambda function is used with the reduce function, the variable x holds the cumulative sum, that is the sum of all the elements that we've seen in the list so far. The variable x does not refer to an individual element, it refers to the cumulative sum of all the list elements that we've seen so far. So if we are on the third element, x represents the sum of the first 2 elements. When we are on the fifth element, x represents the sum of the first 4 elements. The y variable in the lambda, when used in the reduce function, refers to the value of the current element that we are encountering in the list. When we add x to y, we are adding the current element to the cumulative sum and returning a new cumulative sum. The reduce function is in the functools module. So we import reduce from functools, and this is how we use reduce. We pass in first the sum function, and then we pass in the list on which we want it applied. And if we print out the result, we'll get the sum of all the numbers that are present in this list, which is equal to 277. Here is another example of using a lambda with the reduce function. This lambda tries to find the longest name in our list of names. This lambda takes in 2 input arguments, a and b. The variable a will hold the longest name that we found so far across all the elements that we've already seen. Let's say we're looking at the third element, then the variable a will contain the longer of the first 2 names. The value in variable b will be the current name that we are processing in the list, the current element in the list. Observe closely the syntax of the command that is within the lambda. We want to return the value a if the length of a is greater than the length of b, else we want to return the name b. If you run the reduce code, you'll find that the longest names in the list of our names is Pranati. You can compare this against all the names in the list. Pranati is indeed the longest.